everyone, and welcome back to the Smart Tea podcast, where we talk about the lives of scientists and innovators who shape the world. How are you doing, Arpita?
I'm doing okay. I am solo parenting this week. LOL.
Parenting your two cats. Yeah.
My two cats. Logan is on a work trip to New York this week, which is pretty much fine. Like, I feel like I've just been busy with work and stuff. But Poppy is very attached to Logan, like very, very attached. They have like a very cute relationship. Logan goes to bed later than me and then wakes up later than me. And so at night, he'll be like on the couch working or, on his laptop or whatever. And then she will just sit in his lap and purr. Like, she's just so excited. And in the mornings, when I leave for work earlier, she will then go and cuddle with him in the bed before he wakes up. But he is not here this week. And so in the mornings, I wake up earlier than Logan does, and she'll come into the bedroom and she just wails at the top of her lungs.
Oh, no.
And she's just like on the bed, like pawing underneath, like to try to get underneath the covers.
Oh, my
And I'm
goodness.
like, homegirl, I don't know what to do for you. Your dad is not here this week.
Oh, poor thing.
Yesterday, she decided to go on a hunger strike.
Oh, no.
So we are having a little bit of drama. So right before we started recording this evening, I texted Arthi and I said, I'm going to hop on really quickly. Like, I need to feed my cats.
Yeah.
I thought this was going to be a 30-second to 1 minute project where I just, dump their food into their bowls and I was going to come in. And I ended up being almost 10 minutes late because I had to sit there on the floor in the kitchen and basically hold the food on a little spoon to try to coax her to try to eat her food. And she's looking at me like, nah, girl, like, I will not be eating that.
Oh my gosh. I was wondering. I was like, where is she? She said you have to feed the cats. That takes what, like 2 minutes?
No, normally that would be correct.
Yeah.
And then I was like, anyway, she is very drama, but she's also orange. So she only has 3 brain cells at max. And she's very, very sad that her dad is not here. I promise all her biological needs are met. And also Logan comes home on Friday morning. So
yeah, it's just a couple more days. Just hold on.
She's fine. She just looks at me and she's like, You're not what I want. Like, what do you mean? What have I done to you?
Yeah, I'm your mom. Come on.
I know. like I'm your mom.
Yeah. Oh my goodness. That's
so we have some
funny.
Dramatics over here in this household.
That's so funny. I mean, yeah, when Cairo gets left, like if I have to leave or my brother has to leave or something, usually there's like still someone at home. So he gets sad for like the first day, but like after a second day, he's like, okay, well, I guess this is the new norm. And he just like goes along with it. But he has never, ever gone on a hunger strike, like ever. So it's like a foreign concept. Yeah.
I know. I feel like Peppy is so food motivated and he is, I don't think, is capable of being on a hunger strike.
Yeah.
And Poppy has decided that she's on a hunger strike now. So.
Wow. Good luck with that.
Yeah, I know. This is just so dramatic for no reason. But what's going on with you?
In exciting news on my end, I got a new desk. It is an ergonomic desk, like it adjustable up and down.
Welcome to the 21st century, Arthi.
I know. Thank you. It was months literally where I was like, my right shoulder hurts really bad. And I equated it to using my computer mouse all the time. So then I went into research. I asked my friends and they were all like, you need adjustable desk and you need a better mouse and you need a better keyboard and you need a new monitor. And so I'm like, okay, one step at a time. So I've got my desk, I've got my new mouse, and I am learning to work with all of it. I'm just playing with my desk, going like up and down, finding the right height for me. And yeah, it's a lot of fun.
Your physical therapist friend is very proud of you and approves of this.
Yes. She's the one who helped me a lot with it, actually. So
I literally meant me, but yeah, that too.
Oh, yes, you too. Sorry. Yes. Yeah, but it's really helped improve my posture. Like, I knew that I had to sit back in my chair more and like keep my shoulders straight more, but I was always just unconsciously leaning forward.
Oh, and I do that all the time.
My shoulder was like in this weird, like twisted position all the time. And I just could not get out of that. But now it's like magic with with this desk. I can actually like slide my legs all the way underneath and I can sit straight up. So very excited about that.
My thing is always that ergo setup are always just like so ugly. And I'm like, I do
Hmm.
not want that in my house. And I'm like, what is the cute version of the sit to stand desk and the mouse that isn't just like so funky and weird and so strange looking that I don't want it on my desk? And like, how do I get an ergo
Yeah.
chair that isn't this chunky black gamer chair that a boy would have in his bedroom? And I'm like, this is
Yes.
like, you can see my background. Like, we are cute.
Yeah.
This is cute. This is a girl's
Yes.
room. Like, I don't want the weird gamer
I
chair.
want something cute and functional, please.
Yes,
Please.
thank you.
Yes.
I think that intersection is very important.
Yeah, and very rare to find, I think, in women's
Agree. I
stuff.
know.
It's hard.
It is hard.
Guys get all the comforts of life. We women
It's
just have to
true.
put up with stuff.
It is true. It's true. Well, before we dive into our story today, we have an announcement. I am leaving Smart Tea Podcast. I've been thinking about this for a few months now, and this has been a really long decision that I've made. And Arthi and I have been talking about this for several weeks now behind the scenes. And this is the first time that we're sharing it with all of you. And it's certainly not because it was a secret, but more because we were trying to figure out what this would look like for us and the podcast. And it's been so fun to try something new. Both of us were really so excited about science communication, and that's how we got connected in the first place. And I wanted to challenge myself to try to experiment with a new medium, which is a podcast. It's something that I'd never really done before. And together we figured out so many things like audio editing and what software to use. And you guys were there with us through all the kinks. But
Hmm.
I'm starting to realize that there are a lot of other things going on in my life that just isn't giving me the bandwidth to fully dedicate to this podcast the way that I would like to. And it feels super bittersweet because there's this part of me that very much felt like I was letting Arthi down, like letting the podcast down, letting all of you down. And I don't want that to be the case. Like, I'm still going to be such a huge fan and I'm turning into a listener and the podcast isn't going
Yes.
anywhere, but it is something that it wasn't a decision that was taken lightly is really my summary point. But yeah,
Yeah.
that's our news.
Yeah. And I am so thankful to you for, starting this with me because I think it was your idea originally. You asked me, like, have you ever thought about starting a podcast? And I was like, not
I don't even remember that.
seriously. Yeah, you did. You like, we were just chatting and you were like, by the way, have you ever thought about starting a podcast? And I was like, well, not seriously because I couldn't do it on my own,
Right?
And we were like, well, if we come up with an idea for a podcast, maybe we could do it together. And so that's kind of how the podcast got started. I never would have started it without having you like by my side to
Same.
help me because I also like didn't know anything about audio editing, podcasting, like,
No.
it's a whole new medium. I didn't know anything about it. Like, I was just like, how do we get this onto Apple Podcasts? How do we get it on like Spotify? I don't
How do we
know.
edit? How do we
Yeah.
so
How do we do
many
any of these
different
things?
things.
Yeah. So it was a huge learning curve. But like you said, the podcast isn't going anywhere. Although Arpita is leaving, I have found someone to help me carry on the podcast. Her name's Maria. She's actually my best friend from, gosh, I met her in 6th grade. So I don't even know, like, what is that, 25 years or something that we've known each other? Yeah. So she's going to be helping me carry on the podcast. I'm really excited. And she's super smart. She, also has her doctorate in physical therapy, just like Arpita.
I love that there's
You
still
know,
going to be a PT on this podcast.
Yes. Complaining about my posture.
Yeah,
like
literally.
I'm not sitting right. Yeah. So she has that background. She has a master's in electrical engineering. She's just super, super smart, way smarter than me, actually. So she's going to be bringing a lot of new knowledge to the podcast. So I'm really excited to have her on. And it's just going to be fun doing the podcast with my best friend also. That also sounds like a great time to me. So,
No,
yeah,
completely.
but Arpita's going to stay on until the end of March. So she's going to tell this story and then listen to one more from me next time we do an episode. And after that, my friend Maria will take over. So, yeah.
Yeah. One thing that we were talking about, and something that I really wanted all of you and also Arthi to know, is that I feel super proud of what we've built together, but I also want this to turn into like an iteration of what it is currently. And so
Mhm.
I'm really excited to see what you and Maria do together. It sounds like we're going to get some new scientists with things that she's really passionate about and interested in, and maybe get
Yes.
some more deep dives into math and electrical engineering, it sounds like, because
Yeah.
it's not something we can do, I think has been proven
Yes.
time and
I'll
time
I'll have
again.
another engineer in my corner who can help me figure out some
Exactly.
stuff. Yeah. So,
Exactly.
yeah, she'll definitely bring some new topics of conversation to the podcast.
Totally. And I love that. And yeah, like I said earlier, I am planning to be a full fan and listen to every episode, and hope to be back for maybe guest episodes in the future and support
Absolutely.
both of you in any way that I can. But it's definitely a bittersweet moment, but it is, I think, the right decision for me.
Yes. Well, we're sorry to see you go, but I totally understand. Like, podcasting is a lot of work. It is so
It is.
much time it takes to research these people, make sure you have everything accurate. And that's just before you even record the episode. Afterwards, there's all this editing that needs to be done. And, there's just a lot. It's a lot of work. It sucks up your time like no other. So I
It
totally
does.
do understand your decision. And I'm so grateful that you've been part of it for the past more than a year now. And
Thank
but
you. Yeah, it
before
is.
you go,
Yes.
it's time for you to tell your last story of the podcast.
My last story. Okay, so I also
Yes.
belabored over what story to do, because I was like, I have to make this so good now. And I was like, this has
Yeah.
to be like the best story I've ever told.
Yeah, it has to be amazing.
I rewrote this story so many times. I actually changed people twice because I was like, this isn't good enough. Like, I'm like, this isn't a good enough story.
Oh
This
my
person's life
goodness.
isn't interesting enough. And I was just like, God damn it. And I don't know, agonized over this. And now I'm like, this is going to be the most mid story ever
Oh
because
no, it's
I
gonna be
maybe
great.
overcorrected.
It's gonna be
Well,
great.
I was thinking about all the other episodes I've done, and there's like a few that stand out in my mind of ones
Mhm.
that I feel like particularly excited about. Like, I feel really
Mhm.
excited about Albert Hoffman and the LSD episode. I really like the episode on psychedelics. Like, these are some of the
Mhm.
stories that like stand out to me. And I was like, it has to be better than that. And I'm like, those just happened organically. And I'm like, I just need to chill. Is really,
Yes.
I need
Yes,
to
you just need to
relax.
relax. Yeah.
Okay, so that mid and maybe wonderful and also maybe terrible story that I will be telling today is about Jose Manuel Rodriguez Delgado, who I had never heard of before. And he is known for groundbreaking neuroscientific innovation, and he is also has a lot of ethical controversies around him.
Oh,
And I was really excited about him because my PhD was in neuroscience, and I feel like we actually haven't had that many neuroscientists,
we
right?
haven't.
We haven't.
No.
So I was really excited to learn about his story, and there's also some like interesting twists that I'm excited to tell you about. So Jose Manuel Rodriguez Delgado was born on August 8th, 1915 in Malaga, Spain. And because he is Spanish, his mother's family name is Rodriguez and his father's family name is Delgado, but his last name is actually Rodriguez Delgado. From here
Okay.
on out, I am actually just going to call him Jose because
Mhm.
it's too long.
Yes. It's yeah, that's a mouthful for sure. Yeah.
He's the son of Rafael Rodriguez Amerigo, and his dad was a direct descendant of Amerigo Vespucci, who was the 15th century explorer who was the first person to recognize that North and South America were new continents after Christopher Columbus initially discovered them. So he's the one that America is named after, Amerigo Vespucci.
Oh,
So
interesting. Interesting
there,
little tidbit.
yeah, interesting little tidbit. That doesn't come up again ever in the story, but that
Yeah.
he's a direct descendant of Amerigo Vespucci.
Okay.
So Jose is the second of three sons, and I truly could not find a single thing about his childhood. But when he was a young adult, he enrolled in the University of Madrid right after high school and started working on his medical degree. And this was right before the Spanish Civil War. And so he went to medical school hoping to be an ophthalmologist because his father was an ophthalmologist also.
Okay, gotcha.
And so his early life was really deeply intertwined with the socio-political kind of upheaval that Spain was having. So he's just getting to college and like working on medical school when the Spanish Civil War breaks out. And this was a brutal conflict that involved the left-leaning Republicans and the right-wing nationalists, which were basically fascists. And the fascists were led by Francisco Franco. And the end of the Civil War resulted in the nationalist victory and then led to a decades-long dictatorship in Spain. So Jose was basically just starting medical school when the Civil War started in 1936. So he participated in the war as a medical corpsman on the Republican side. And this like really influenced him because he experienced firsthand some of the horrors of armed conflict and some of the results of that, and how people were affected with PTSD and all of these other things like coming out of like witnessing these really horrible things.
Yeah.
And at the end of the war, he was actually held in a concentration camp on the fascist side for 5 months before he was released. So
oh my gosh.
As a really young adult, he experienced some of these like really, really tragic things and that were very formative for the rest of his life, understandably.
That would be so scary to be witness to that young.
Definitely. And so this was a very, like I said, very intense personal experience and definitely shaped his worldview. And he had this now profound understanding of human suffering and fragility of life. But then he also became interested in PTSD and anxiety and panic disorders, which will then come up a little bit later in the story.
So they didn't call it that back then, right? Like it wasn't called PTSD or...
No.
There.
I am adding that.
Yes. Okay. Just
but
making
he became
sure.
Basically interested in like psychological disorders.
Yeah. Okay. Yeah. Gotcha.
So after the camp, he had to repeat his MD degree. I can't figure out why that happened. Maybe there was like, the only thing I can think of is that somehow it like timed out or something where like you needed to finish your degree in a certain amount of time or something. I don't know, but I checked multiple sources and it said that he had to repeat his MD degree. And I asked ChatGPT why he had to repeat his MD degree. And ChatGPT was like, I don't know.
Really? I'm actually very impressed because I have asked ChatGPT questions like that and it has made shit up. I'm like,
really?
Yes. Like I was trying to do, like not for this podcast, but I was trying for another project I was working on. I was trying to figure out how two founders of a company had met each other. And I was like, going through all these press releases and articles. Right. And I was like, let me ask ChatGPT. And it was like, oh, they met when they were like graduate students in Stanford together. And I'm like, really? Because I'm pretty sure one of the founders didn't go to Stanford. And so I like double checked and I'm like, yeah, he didn't go to Stanford. And so then I asked ChatGPT, like, what is your source for this? Like, can you give me the original source? And it was just like, oh, I just made a best guess based on how these things usually happen. Usually founders meet each other in graduate school. And so I just assumed that that's probably what happened. And I'm like, you can't just say that. Like, no. So I'm really like, it seems like it's taken a step up since then and just went straight to, you know what? I don't know. And I'm like, I respect that. That's fine. If you don't know, it's okay.
Well, ChatGPT basically said, there is not much known, is what. And then I was like, okay, great. That makes me feel better because I'm scouring the internet right now. And anyway.
Okay.
So then he repeats his MD degree and then he goes on to get his PhD at the Ramon y Cajal Institute in Madrid. And though he initially wanted to be an ophthalmologist, once he discovered all the writings of Santiago Ramon y Cajal, he changed his mind. And as we know, Santiago Ramon y Cajal was a Spanish neuroscientist and pathologist who is very widely considered the father of modern neuroscience. And he revolutionized our understanding of the nervous system. He did a lot of work in understanding what neurons were, and he has these like beautiful drawings and illustrations that if you have not seen, you should absolutely go see. He's like the OG science illustrator. And he has, I think, inspired generations of neuroscientists at this point, but including Jose.
Can I tell you something?
Yeah.
Okay. So I've actually already started my story for the next.
Is it Ramonica Hall?
Yes, it is.
Oh my
I
gosh,
was like,
amazing.
when you started this story, I was just like, how are we on such a same wavelength? I think this happened like last time too, because we both did like Pasadena based
Oh yeah, that was
with
funny.
Charles Richter and Jack Parsons, like both, California, Pasadena based
Yeah, that was funny.
scientists. And now you're like, oh, we're talking about like this Spanish neuroscientist. And I'm like, we did it again. Like, how did this
Ramonica
happen?
Hall is a really good one. I'm excited about that.
Yeah. So I just, it's coming next.
Okay,
And
great.
now I'm locked in.
Awesome. I love it.
Yeah.
Okay, so our OG science illustrator, and then Jose was inspired by him, and he decided to pursue his passion for neuroscience. And he started spending some time in a physiology laboratory, and he became very captivated by all the mysteries of the brain. And he said, quote, "How little was known then and how little is known now about the brain."
Still true.
I agree. And as he was starting his explorations, he wanted to do experiments on primates, but he had a really hard time finding research animals. And just as an aside, as my little editorialization here is like, we are back to me soapboxing about no research standards and
Yes.
guardrails around the types of experiments that you are allowed to do. And this isn't even that long ago. Like, this is the 40s. Like, this isn't like the 15th century or anything like that. But even then, what is the funny acronym for the animal? It's like something with an I.
IUPAC?
IUPAC.
Mm-hmm.
Like, there's no IUPAC guidelines or trainings here at all.
I forget what it stands for.
International
Union of Pure and Applied Chemistry. Okay.
No, wait, that's not it.
That's not what we're thinking of.
No, it's not. It's like IACUC. IACUC, is that right?
Institutional Animal Care and Use Committee, IACUC.
Yay!
Okay. I did not know that because I've never dealt with them. So.
Oh, do worms not count?
No, they're basically bacteria. So I've never had to.
That's funny.
Yeah.
Because I definitely did have to do that for some rotation labs because they were like mice labs and you have to do the IACUC training. Mm-hmm. But my PhD lab was not. It was human subjects research, but that's funny.
Yeah. Yeah. I never had to deal with IACUC.
Okay, well, neither did Jose. So
great.
Maybe not
yeah.
great. So he is trying to find primates to do research on. And so in an interview many years later, he said that he traveled to Africa to purchase an animal. And then he had to take a 2-week return journey on a ship with a gorilla. And then he ended up bonding with the gorilla. And he was like, now I felt like I couldn't operate on my friend. And then he donated the gorilla to a local zoo. So, IDK.
Yeah.
He did get over it, but
yeah,
later on, this like kind of period in his life where he was still kind of doing his PhD became known as, quote, under the fascist regime, end quote, by some of his, I'll just call them enemies, because his work was controversial and people who didn't really support him tried to imply that he was associated with the fascist regime in Spain, even though he actually did serve on the Republican side and he was incarcerated and he actually really didn't support the fascist regime at all, but they kind of just tried to like pin him as that because they didn't support the type of research he was doing.
Mm-hmm.
In 1946, he immigrates to the United States and he gets a fellowship at Yale, and he's in the Department of Physiology under the direction of John F. Fulton. And Dr. Fulton was a neurophysiologist and a medical historian, and he was really well known for his research on the cerebral cortex, and he was like a really powerful mentor at Yale. And so after Jose's fellowships in 1950, he accepts a position as a professor in the physiology department at Yale, and he's still sort of working with Dr. Fulton. And this turned out to be really pivotal in his career because it gave him a lot of freedom and resources to basically do whatever he wanted to experiment with brain function.
Okay.
And then some context for the 50s is that this was like a very key turning point in the field of neuroscience. So neuropharmacology, or giving drugs to people, it was just getting off the ground because there was a new drug that was on the market called chlorpromazine, which was one of the very first antipsychotic drugs, and it was being given to patients with schizophrenia. And so the field in general was becoming very excited about one, what do we know about the brain? And two, especially based on disorders, which were categorized very differently than the way we think about them now, which is what you brought up earlier. But like, how can we treat them? And so especially neuroscience and neuropharmacology were very exciting to a lot of people.
I can totally understand that because the brain has its own challenges, right? Like any drug that you give, the brain has to also cross the blood-brain barrier.
Right.
And so that was probably like a huge challenge for them at the time, like getting the drugs to be small enough that they could like cross that barrier and go through into the brain and treat the tissue there. Yeah, that would have been tough.
And it was also just because no one really understood any of the physiology at all. So even designing a drug was really challenging of just like, what would its...
Because your brain is just so complicated.
What would its agonist even be? Exactly.
Like, like what
like,
part...
what is the target for the drug? Like no one even really knew.
Yeah, what part of your brain controls what? What part of your brain is messed up right now? Like, yeah.
Right. Exactly. So that's kind of like the general landscape of where this story is taking place.
Hi everyone, Arti here. I hope you're enjoying the podcast. If so, and you wish someone would tell your science story, I founded a science communications company called SciComm, that's SYKOM, that can help. SciComm blends creativity with scientific accuracy to create all types of science communications content, including explainer videos, slide presentations, science writing, and more. We work with academic researchers, tech companies, nonprofits, or really any scientist to help simplify your science. Check us out at scicommer.com. That's SYKOMMER.com. Okay, back to the story.
So in 1956, Jose was in his early 40s and he met Caroline Stoddard. She was 22, very pretty, and the daughter of a Yale administrator, and the two got married within the year. And then they had 2 children in the following years, Linda and Jose Carlos. And Caroline fits very squarely into the bucket of devoted professor's wife, where she was very passionately devoted to her husband's work and was even a little awed by it. And there's a New York Times piece that I referenced for researching this, and they interview her. And the quote in the paper was, Caroline said without irony that my husband is, quote, the great Delgado, end quote. And I was like, I was like, I love my partner very much and would still never, ever say that because that is crazy.
Yeah, I mean, but I do like my grandmother is kind of the same way. So I think this is like the same
like
kind of generation type of thing. Yeah.
Like, that's cuckoo bananas. I would never say that.
I get, like, I've witnessed that mentality firsthand from her. So like, I know what you're talking about.
I was like, okay, girl.
Yeah.
That was my reaction when I read it.
Yeah. There's a difference between love and respect and then like worshiping.
Yeah.
Yes. Yeah. There's a line there.
Okay, great. I'm glad we agree. So Caroline does worship her husband, and she didn't work, but went to lab with Jose every single morning and then spent the day in the office editing and typing papers. And she said she loved being with someone, quote, so optimistic. It's a constant circus. It's fun to see what's coming next. The brain is a relatively new field, and there's a tremendous feeling of excitement, end quote. And I'm like, I sort of get it, but also like, I think perhaps chill, but that's just my
It's nice that she was involved, though. Like, I'm glad that she was able to help him in his research, and
it's true. You're just a better person than me.
Well, I think I've just seen the opposite side where people are not involved at all or like don't care, and it's like
that's fair.
You should care a little bit, right? So
she cared a lot.
Yeah, like, care what your partner is doing with their life, and try to support them. So I'm happy that happened.
You know what? You're right. A lot of the quotes are straight from this New York Times article, which if anybody has like 15 minutes to kill, it is such a weird article that got published. Yeah, it was like a 1971 paper.
Okay.
So it's like from the New York Times archive. But I was like, what is going on?
Yeah.
Which I think will become apparent in the rest of the story.
Okay.
So in his research, Jose sought out a less invasive approach to brain intervention. And so he was really preferring electrical stimulation over traditional brain surgery and drug administration. So he felt that both drug administration and brain surgery were inefficient and imprecise because there was usually a lot of consequences from brain surgery. And in drug administration, you couldn't be as precise. So he was starting to experiment with electrical signals to evoke brain responses. He first started with cats, and then he later expanded to monkeys and even human psychiatric patients. And this research led to the development of the stimoceiver, which is a device that allowed for remote brain stimulation in freely moving individuals.
Whoa, that sounds crazy. Wait,
No, it's crazy.
remote brain stimulation?
Yes.
Like you press a remote and someone over there gets shocked by...
It's like less of a shock, but it's more just like adding in an electrical impulse that stimulates the exact cortical region that you're interested in.
Whoa. Why is it remote though? Like, why does it have to be remote?
It's remote because they're not tethered to anything. So it's basically like they're living their day-to-day life and they're doing all these things. Actually, this is my next paragraph, so I'm just going to read that.
Great. Yes.
So the stimoceiver was a wireless implanted device. So it allowed for remote electrical stimulation and recording of brain activity, which allowed researchers to observe behavioral changes in freely moving subjects. So basically what they did was implant a small, like super tiny fiber that had the ability to receive and transmit radio signal. And there's like a remote basically somewhere away from the person. And then when that remote was pressed through radio signal, they were able to then activate or stimulate that one area that fiber was being placed in. So they did have to do some surgery where they had to implant the fiber. But imagine it almost like a precursor to a DBS or a deep brain stimulator. It's like not quite as fancy, but it's like the grandfather of that.
It kind of reminds me of like those continuous glucose monitors that some diabetic patients have, where it's like inserted under your skin and then it reads your glucose levels and like sends that information to your phone so you can track that. And then some, I think, even release insulin if you're low. So
like a pump. Yeah. It is similar to that.
So it's something except it's like that.
Imagine that, but it's actually providing a stimulus also.
Gotcha.
Very similar.
Yeah.
So like he got really good at this. So some of them were even as small as $50, which allowed the subject full freedom of movement. And it basically didn't limit any of their activities. It wasn't in their visual field or anything like that. So then it removed a lot of limitations of traditional laboratory experiments, which allowed researchers to observe the effects of brain stimulation in a way more naturalistic setting. And so what this really did was revolutionize neuroscientific research by providing a means to precisely manipulate and study brain function. So today, similar methods that we'll use, especially in animal studies, are optogenetics, which is done by inserting genes that encode light-sensitive proteins into specific neurons. So by shining a particular wavelength of light into these neurons, we can precisely activate or inhibit their activity. So if you like, you can particularly turn on some neurons or turn off some neurons by basically breeding these animals with certain genes that encode these proteins.
Optogenetics was huge in worm studies, by the way.
Really?
Yeah, because the worms are transparent. So you don't have to do any surgery. You can just like have a plate of worms that are genetically altered with this like light sensitive gene. And we saw so many videos when I was in grad school of like the light is off and all the worms are just kind of crawling normally.
It's really cool.
And then you turn blue light or some, specific wavelength of light, you turn that on and then all the worms start like making little circles because whatever gene that they've been encoded with only allows them to make left turns. And so they'll
the
like
motility or something.
They've like messed with the motility. So you can see like blue light is on and they're all like making little circles. Blue light is off and they start crawling normally. Blue light goes on, they make little circles.
That's super cool.
We got all these videos like that. Yeah. So it was huge in worm studies just because it was like, oh, it's so easy. They're transparent.
Totally.
So you don't have to worry about like, how do you get the light shining on the actual brain?
Right. Right, that's true.
Yeah.
So optogenetics is obviously way more precise because you're coding it on specific genes, so you can be really precise about which neurons they use, which is obviously better. And then other tools that we have like brain-computer interaction or BCI can do similar things by enabling direct communication between the brain and external devices because it translates neural signals into actionable commands. So those are like
Mhm.
the, I guess, downstream or like more modern sort of analogs to the stimoceiver. So back to the stimoceiver, Jose found out that it could be used to stimulate emotions and control behavior. So according to him, quote, stimulation of different points in the amygdala and hippocampus provide a variety of effects, including pleasant sensations, elation, deep, thoughtful concentration, super relaxation, colored visions, and other responses. Brain transmitters can remain in a person's head for life, and the energy to activate the brain transmitter is sent by radio frequencies, end quote. So he's basically finding out that he could stimulate sensations and thoughts and emotions by activating different parts of the brain.
How far apart do the remote and the patient have to be? Like, it's by radio wave, but like,
Yeah, I actually
is
think
it?
it's pretty far.
Oh,
Like,
really?
yeah. There is a later experiment which makes this kind of obvious. In the sense of like,
Okay.
I don't think you could
Like the
be.
patient can't be at home and he's in the hospital. Like, that's too
No,
far.
no, no, no.
Yeah.
No, I think that's too far. But I think you don't need to be like next to each other. Like you can be
You could
decently
probably
far.
be in the room next, like the next room over, maybe.
Probably.
Okay.
Probably. So like, I mean, for the, like it's pretty good is basically the summary.
Yeah.
And so he found that it could not just elicit emotions, but it could also elicit specific physical reactions. So these reactions, such as the movement of a limb or clenching a fist, were achieved when Jose stimulated specific parts of the motor cortex. So when he had implants that were stimulated to produce a reaction, he found human patients that were unable to resist the reaction. And one patient said in this same weird New York Times article, quote,
Mhm.
I guess, doctor, that your electricity is stronger than my will, end quote. And so it's basically that they're involuntarily moving because parts of their motor cortex are being activated.
It's like when you get hit with like at the doctor's office with
Yeah,
the
like a
little
reflex
hammer and
hammer.
it makes you, yeah, the reflex hammer, it makes you like
That's funny.
pop your knee. Yeah. But
Yeah,
it's
or I guess,
happening electrically now.
yes,
Yeah.
exactly, which is like really weird. And one of his most promising finds was related to an area in the brain called the septum varum, which is a structure in your limbic system and also known as the part of the brain that controls stress and emotions. And so when stimulated, it produced feelings of strong euphoria, and they were sometimes strong enough to overcome physical pain and depression. So he felt like this could really
Whoa.
be helpful for some psychiatric disorders.
Mhm.
In another experiment that he did, he stimulated a certain point of the cortex in a cat, and the cat began the motions of licking every single time. And if the cat was sleeping, it started licking in its sleep. And if it was awake, it looked around for a bowl of milk to drink. And if there was no bowl, it started licking its own fur. And his hypothesis was that the cat seemed determined to make sense out of like what it felt compelled to be doing. So it's either like licking its
Interesting.
own fur or trying to lick the food.
Yeah, it's like I'm licking something. There's no food though, so I must be trying to clean myself. That's so
Yeah,
interesting.
super interesting.
Yeah.
He had another experiment with a monkey named Ludi, and he found that when her red nucleus was electrically stimulated, she consistently exhibited a complex, repeatable sequence of behaviors, including stopping her current activity, turning her head, standing and circling, climbing and descending a pole, displaying aggression, and then becoming friendly, a pattern that occurred in the exact same order across 20,000 stimulations.
Oh my
And
goodness.
so he's finding that there's just like these really clear outputs to like the parts of the brain that he is stimulating.
That's like extremely specific. It's like that one part of your brain is responsible for you stopping what you're doing, climbing a pole, and then going and being friendly, like in that
Yeah,
order every time. Like that's
every
just
time.
crazy.
It is crazy. And it's like also like a little bit individual, right? So it's like if that
Yeah.
part of your brain has been plastic and mapped to do a certain thing, it's probably not the same between you and I, but
Right. Right.
exactly. It's super
Yeah.
interesting.
That's so fascinating.
So his most famous experiment, which I think gets to your point of how far did you have to be, was when he was in Cordoba at a bull breeding ranch. So Jose very famously stepped into the ring with a bull which had a stimoceiver implanted in its brain, And the bull fully charged Jose, and then Jose pressed a remote control button, which caused the bull to stop in its tracks and stop the charge.
Oh my God.
This video exists, and it's super blurry and grainy, but it is legit. He was kind of like a little theatrical about this, and so he taped the stunt. And there's a photograph in said New York Times article. And the region that he was controlling was the caudate nucleus, which is chosen because of its involvement in controlling voluntary movements, because it's kind of involved in the motor cortex. And he claimed the stimulus caused the bull to lose its aggressive instinct. But later on, scientists think that it's probably just because it was like a motor thing. It's not necessarily the bull was not aggressive. It was just incapable because of a motor cortex block, which is interesting.
Either way, I don't think I would ever have enough faith to be able to do that or like trust.
Yeah.
Oh,
it's crazy.
I could not. Oh my goodness.
So this was by far like his most famous experiment. And he basically was able to demonstrate that stimulating the specific area of the brain could result in a very clear output. And people were really excited about this, but also like people were very weirded out. And so it raised a lot of profound questions about free will, autonomy, and the ethical implications of such power. And so the scientific community was basically arguing for the fact that there was a lot of valuable insights into neural mechanisms and understanding behavior and emotion, but it also sparked a lot of intense debate about the ethics of and misuse of or potential misuse of this technology, which is valid.
Yeah, like you can just implant this thing and make people do whatever you want them to do or feel however you want them to feel. Like yeah, you need a whole ethics committee around that.
Yeah, multiple boards of ethics.
I mean, even with animals, getting animals to do what you want them to do has to be really strictly regulated.
No, you're completely right. And so even though this was the most widely mentioned experiment in popular media, he actually believed that a different experiment, which involved a female chimpanzee named Patty, was his most significant experiment. So Patty had a stimuloceiver that was linked to a computer that detected a brain signal called a spindle, which was emitted by the amygdala. And when the spindle was recognized, the stimuloceiver sent a signal to the central gray area of Patty's brain, which controls behavioral responses to threatening stimuli, which then produced an aversive reaction. So in this case, the aversive reaction was an unpleasant or painful feeling. And the result of this was a negative feedback loop to the brain. So within hours, her brain was producing fewer spindles as a result of this negative feedback. And as a result, Patty became quieter, less attentive, and less motivated during behavioral testing. And then once it was removed, went back to her normal self. And so even though this was not exactly ideal, he was hypothesizing that this method that was used on Patty could be used in others to help turn on and turn off and synchronize unpleasant stimuli with pleasant stimuli to help people with panic attacks, seizures, and other disorders controlled by different parts of the brain. So what he's basically trying to do is connect two parts of the brain together. So like when one part of your brain fires, it actually like will stimulate a different part that results in this case, was unpleasant emotion, but could be pleasant emotion in a different scenario.
So it could be that whenever someone was feeling depressed or feeling anxiety or some negative emotion, whenever your brain registered or whatever part of your brain that controlled anxiety or depressive thoughts fired, it would then trigger the electrical stimulus that would actually make your part of your brain that was happy and euphoric trigger. And so then you would, whenever you're having depressive thoughts, it would trigger your happy emotions, so that it would pull you out of that, hopefully.
And override, basically. Exactly. Another question that he had was whether or not electrically induced rage in cats was a genuine emotional response or just a set of automatic physical reactions. So he conducted an experiment where he found that if he stimulated regions of the brain known to trigger rage while the cat was attempting to eat, they quickly learned to avoid food, suggesting that the stimulation was perceived as a punishing experience. However, if he stimulated other brain areas, it just caused a brief startle, but didn't deter the cats from eating, which indicated the lack of an aversive emotional response, and there was more of a motor response. So he's trying to distinguish now here between emotion and motor.
Yeah. Again, like with the bull, like did the bull actually calm
Exactly.
down or did it just like
Exactly.
physically stop? Okay. Yeah.
Exactly. And I don't know that he really comes to a conclusion, but that's what he's really trying to parse out.
Mhm.
And so he does this study basically on pain centers, or he's trying to understand this in cats. And then another scientist, his name is James Olds. He's in Canada at McGill, and he was like, I wonder if that there's pain centers, there's also pleasure centers. So he implants electrodes in rats, and he is trying to replicate Jose's experiments. And he finds out that the rat finds the stimulation highly rewarding, and he like repeatedly keeps seeking it out for the behavior to stimulate that region of his brain. And so
Mhm.
then he revealed the existence that in addition to pain centers in the brain or unpleasant, there's also pleasure centers in the brain.
Makes sense.
That's the first time someone discovered that. And so Jose was like, oh, cool. Now that there's pleasure centers, I should totally try this on people. And so
Oh
he
my
tried
god.
this on a patient with psychomotor epilepsy. So this 30-year-old woman was implanted with electrodes. And when this very specific point in her temporal lobe or the pleasure center was stimulated, she expressed strong feelings of affection towards the therapist, a person who she had never met previously, and she displayed like these grand emotions, and she like went up and like hugged and kissed this therapist. And then as soon as the stimulation was turned off, she like went back to her normal self and like didn't even really register that that was weird or it happened. So
Wait, so she knew it was happening.
yes,
She just didn't think it was out of the ordinary that she would have
correct,
done that.
correct.
Weird. Oh
Weird,
wow.
so weird,
That's
so
so
weird.
weird.
And basically all of these are basically telling him, and going back to some of his interests in psychiatric disorders, he really felt that brain stimulation was less invasive compared to traditional brain surgery. So instead of removing brain tissue, he could insert really thin wires to monitor brain activity. And what he really wanted to do was allow doctors to pinpoint the source of problems in the brain more accurately, which would then allow for treatment, which would either destroy that area by like cauterizing it or excising it or something, or stimulating another brain region to counteract, like what we kind of saw earlier, where you could
Mhm.
override a negative stimulus. And that was kind of like what he was hoping to achieve.
Oh, wow. So this is a really powerful tool because it could potentially show brain surgeons exactly which area they need to remove, or it could be a constant tool that you just use every time you're feeling something negative or something bad is happening.
Yes, I think it's more likely to be the second thing. The first
Mhm.
thing is a little bit hard and I think was a lofty goal of his because it did still involve an implant. Like you still had to attach this filament to someone's brain. And then if you
Mhm.
didn't actually know where it was coming from, it would probably require you to rinse and repeat a few times in order to find the
Mm,
correct spot. So
yeah.
I don't know how well it would have actually worked for that, but I
Mhm.
think the second thing is right, in which if
Okay.
you're able to detect something, you're maybe able to override or stimulate a different part of the brain if that is maybe more desirable.
Interesting.
That is my like editorialization.
That makes sense though. Yeah, cuz I think even now brain surgery is kind of like a bit scary to think
Totally.
about, because it's not as forgiving, I think, than other types of surgery. Because if it's like if you scrape just a little bit extra or you miss a little bit that you were supposed to get, it can have really strange and kind of unpredictable consequences
Definitely.
sometimes. So, yeah.
And if someone is a neurosurgeon in this audience, let me know and fact check me. But like
Yeah.
my Grey's Anatomy days, there was definitely those episodes where Derek Shepherd would operate on someone while they're awake because he's stimulating different parts of their cortex, and he's like, "Do you
Mhm.
feel this? And do you feel this? And do you feel this?" Because he's like trying to get to like the right part of the brain. I'm like pretty sure
Yeah.
that's true, but I mean, also is Grey's
I
Anatomy. I don't
mean,
know.
House did the same thing, so
Okay, great.
I haven't yeah, I haven't watched Grey's Anatomy, but I watched House, and they definitely had episodes where
Yeah,
they were doing, like, the same thing, so,
is
yeah.
House a neurosurgeon? I thought he was something
No, he's
else.
a diagnostician, but
Yeah. Okay. Right.
he runs the gamut, like, everything's wrong with everybody, and he's
Yeah.
definitely
Yeah. Yeah. Yeah.
treated
Yeah.
neuro patients before, like,
Sure.
just
Sure. Sure.
it makes for the drama,
Yeah.
so,
No. Of course. Of
yeah.
course. Okay, so he is doing all this while he was a professor at Yale, and while he was doing research, he also taught graduate, undergraduate students. And from his students and his colleagues, he was known to be pretty restless and kind of eccentric. I think we've kind of covered that. And he was so passionate about his work that some people called him the evangelist of brain stimulation. And back to the New York Times article. This reporter asks him about his family and his personal life, and he told reporters, quote, "What do you want me to tell you?" And then he got irritable. And then he said, quote, "I don't want to talk about my wife, my family, or my friends. That is not science," end quote.
Oh my
So
God.
back to the
That's
earlier
such
point of like,
yes.
I couldn't find anything about this man. It took me so long to find anything about Caroline to begin with. So then it's like, this is the reason why.
Yeah. I found it like such a stark contrast too, where he's like, what do you want me to talk about my wife and my kids for? And then the wife is like, he's a genius. He's just so amazing. Like, I'm like,
for real though.
What? You don't want to talk about how your wife supports you in the lab and takes notes and does all that? Like, no.
He did not, in fact. He did not. He did not. He did say this next quote, which is, I think this is why people called him the prophet, quotes. He said, "The human race is at an evolutionary turning point. We're very close to having the power to construct our own mental functions through a knowledge of genetics and knowledge of the cerebral mechanisms which underlie our behavior. The question is, what sort of humans would we like, ideally, to construct?" End quote. Yeah. So this is why he was very controversial. So
it's giving eugenics a little bit.
It's giving eugenics a little bit. And so he's kind of doing this again against the kind of backdrop and landscape of a lot of neuropharmacology. And so he argued that drug therapy controls patients by altering their overall behavior and often caused harmful side effects, which include lethargy and cognitive impairment. And he was really questioning whether it's more ethical to offer precise targeted stimulation to correct specific neural malfunctions. But this was met pretty poorly by the general medical and scientific community because they were like, "This, it's giving eugenics," is basically the summary here.
Yes. Yeah.
And so, like we might expect at this point in the story, he was met with a lot of criticism and people were not super excited about some of the stuff that he was doing. And so aside from the fantasy and some of the fears that were, spurred by some of the experiments, there's also like a lot of criticisms about his techniques and his methods. So one Yale colleague said, quote, "There's something idiosyncratic about the way he works. He doesn't follow the ordinary rules or methodological rigor. There must be the slow, dogged part of science, the careful checking of observations, the randomization of experiments, and the estimate of the probability that your findings weren't just due to chance," end quote. And then another colleague said, quote, "José does not seem to have the patience to fool around with any of that. If he stimulates a monkey's brain and gets an expected reaction, he gets bored. He gets a lot of things started, and then he leaves other people to clean up after him. But let's face it, technologically, the man's incredible. He's a real genius in a practical way, a sort of Thomas Edison of the brain," end quote. So it's mixed. People are like, he crazy and he don't do anything right. But also low-key, he kind of did discover some cool shit. So like, do we give him a pass? Question mark.
Yeah. It's like, it sounds like he makes a big discovery. He gets really excited by it, but then he has zero follow through to actually fully test it, fully like cross all the T's and dot all the I's on it.
Yep. Last quote from a colleague, Dan Snyder, said, quote, "He's an inventor in the purest sense. You can't fault his creativity. The man drops gems of ideas in casual conversations the way some people shed bacteria. That's part of the problem. He hasn't time to beat an experiment to death because he's got so many good ideas that he more or less has to be in 10 places at once," end quote. I'm not going to lie, he sounds terrible. Like, I would not want to be in lab with him. He sounds like the worst. But like, I don't know, like all these quotes from colleagues were all in that New York Times article. And it was just like such a mixed bag where people were like, high key, we hate him, but like also low key, he's maybe smart.
Yeah. He would be a terrible professor to study under because he would constantly just be like, "We should do this. We should do this. We should do this." And you would just be like, "I need to publish and get out of here." That sounds, that would be awful. But it's like, he's brilliant. If you can ever get out of his lab, it would be a great feather in your cap, but it's a big if.
Totally. And so around this time, now he's been at Yale for several years, and in the 70s, the Nobel Prize went to a man named Julius Axelrod and his colleagues for the catecholamine hypothesis of depression and neuropsychopharmacology. So he was really hoping that his field of electrical stimulation would be the one that took off in the 50s, but really what ended up taking off was neuropsychopharmacology. And this is actually where we started getting
Mm.
SSRIs, and like that really took off. And electrical
Mhm.
stimulation was really not something that the community at large got behind, even though he was hopeful.
Mhm.
The controversy that surrounded his work, that coupled with this like growing awareness of ethical concerns with the scientific community, led Jose to return back to Spain in 1974. So the Spanish Minister of Education, a man named Villar Palasi, asked Jose to help organize a new medical school at the University of Madrid. And so he took this offer to then get some space from Yale and his work, because it was turning out that people were really not behind the stuff that he was doing. And so he went to Spain with his wife and his 2 children, and he continued research and writing, and he published numerous articles and books that explore the complexity of the brain function and considerations of neuroscientific research. But yeah, ended up staying in Spain for a big chunk of time.
Mhm.
And he wrote a book called Physical Control of the Mind Toward a Psycho-Civilized Society. And in this book, he discussed how we have managed to tame and civilize our surrounding nature, arguing that it was now time to civilize our inner being. And this book has been the center of controversy since its release, and people have hotly debated this. And there's been a lot of like philosophical debates about this. And his intent was to encourage like less cruelty and be more benevolent and happier. But what really ended up happening was #eugenics. So
Yeah. Yeah, 'cause I mean, I feel like this is the thing, like, I don't understand how so many of the scientists, like Alfred Nobel also, they're, like, so smart, but they're like, "I'm making whatever I'm making for peace and happiness, and everybody's living in this, like, golden era of world peace and, bounty," but then it's like, "Yeah, but you created a bomb, though, or you, like, created a
yep,
way to
yep, yep,
literally
yep, yep,
control people." Like,
yep.
you don't see how that could be used for nefarious purposes,
No,
really? You
they
don't.
didn't see that.
Yeah. So, like, I understand your intent is good, but, like, how do you not see the potential bad things that can happen?
I don't think he did. I think he
Yeah,
thought he was a genius. I mean, like, he had Caroline being like, "You're basically God." So, I mean,
that's true.
it wasn't like there was someone checking him.
Yeah, that's true. But, like, yeah. I just don't, I'm like, you're so smart. How do you not see it? How do you not see it? Like,
No
I
clue.
understand you have the best of intentions. Or maybe it's just like how I was brought up to always look at, like, what could possibly go wrong and how do I fix it before it goes
I
wrong?
That's not even on his radar. I
Yeah.
think things are going wrong constantly. In his later years, Jose and Caroline returned to the United States, and they ended up settling in San Diego. And he remained very active in the scientific community until he passed away in 2011, where he left behind a legacy that continues to provoke a lot of debate. So his life and his achievements really are super complex, has a lot of scientific innovation. He really laid the groundwork for a lot of electrical stimulation work, which is still
Mhm.
used a ton in research today and is something that we
Yeah.
really think about, but lots of ethical questions as well. He really did revolutionize the field of neurophysiology and gave a lot of basis to behavior and emotion and how it could be stimulated or turned off in a lot of research. And he also, like I said, raised a lot of questions about the ethical implications of quote unquote mind control and the responsible use of scientific technology. So, if anything, it also just serves as a reminder of the balance between scientific progress, but then also ethical responsibility, which is kind of what you just said, which is you really need to carefully consider potential consequences of discoveries, which is exactly like
Mhm.
the Alfred Nobel episode, and even like Jack Parsons and these people who are discovering really cool things where it's like you did, but also
Yes.
in someone else's hands, what could this do, and what is your ethical responsibility for discovering this?
Yeah.
But yeah, it's a story of Jose Manuel Rodriguez Delgado.
Well, I mean, all your fears of it not being a great story for your last one are completely unfounded. That was amazing. Good
Thank you
job.
very much.
That was so interesting.
The other one that I was going to do that I abandoned was Evan O'Neill Kane. Have you heard of him?
No.
He was a railway surgeon, which basically meant that he was operating outside of a hospital because he was basically like a field trauma surgeon. But
Oh
the
my
reason he was
goodness.
really famous is because he operated on himself without anesthesia to prove that it could be done. And so he basically set up all these
Oh my
mirrors so that he
God.
could had a mirror and was operating on himself. And
Oh my
he
God.
taught us a lot about emergency medicine and trauma surgery because he was doing it with such little tools. And so I thought that one could be really cool, but I just
Yeah.
couldn't find out enough about him. So I did
Mm-hmm.
abandon that one. But that was my other story.
Interesting. Maybe a future episode if I can
Maybe a future episode.
find more information. Wow. But that was really interesting. Thank you.
Yeah, thank you.
Thanks for listening. If you have a suggestion for a story we should cover or thoughts you want to share about an episode, reach out to us at smarttpodcast.com. You can follow us on Instagram, TikTok, and Blue Sky at Smart Tea Podcast, and listen to us on Spotify, Apple Podcasts, YouTube, or wherever you get your podcasts. And leave us a rating or comment. It helps us grow. Special thanks to our editor, James Fix. New episodes are released every other Wednesday. See you next time.